This is section 3.9, derivatives of inverse functions. All right, so the inverse functions, usually students have problems with these because you basically got to memorize them. So what I am circling, or actually squaring, or putting in a rectangle to be precise, is what you got to memorize, okay? So inverse trig functions, remember, inverse sine of x or arcsine of x, we can say y equals inverse sine of x. Remember that your domain is from -1 to 1, or the x values have to be an element from -1 to 1, and my range has to be a value from -π/2 to π/2. I don't know if you remember, like my answer has to be in quadrant 4 or quadrant 1. Negative if it's in quadrant 4, positive if it's in quadrant 1. So once again, the domain becomes the range becomes the domain of the regular trig functions. So if we look at the inverse cosine, or y equals inverse cosine of x, or arc cosine of x, then y equals inverse cosine of x, therefore cosine y equals x. So my domain is -1 to 1. That's what that means. X is an element from the value of -1 to 1. And my range is from 0 to pi, so that's quadrants 1 and quadrant 2. If it's positive, it goes in quadrant 1. If it's negative, it goes in quadrant 2. And then finally, y equals inverse tangent of x, or arctangent of x. So y equals inverse tangent of x, or tangent y equals x. So I don't know if you guys remember, but the inverse tangent function, the domain, is going to be all real numbers, and my range is going to be from -π/2 to π/2, not including those endpoints. The reason why is because you have vertical asymptotes. So that's quadrant 4 and quadrant 1, negative in quadrant 4, positive in quadrant 1. All right, so those are the inverse trig functions. Now we're kind of looking at the derivative of those. So if you take the derivative of inverse sine, the value is 1 over the square root of 1 minus x squared. The derivative of inverse cosine is -1 over the square root of 1 minus x squared. Tangent, the inverse of tangent is 1 over 1 plus x squared, and the derivative of cotangent is -1 over 1 plus x squared. The derivative of secant is 1 over the absolute value of x times the square root of x squared plus -1. And the derivative of cosecant inverse of x is -1 over the absolute value of x times the square root of x squared -1. Do you guys notice that everything that starts with a letter C, cotangent, cosine, and cosecant, its derivative is negative? So that might be a way for you to kind of remember it. And the other thing is another way to memorize this formula is the two inverse trig functions that start with the letter S have subtraction in the square root. So there's a subtraction in the square root of sine and secant as well. So that might help you. Just look for some similarities. And because, we can't just have a regular function, it has to get a little bit more complicated, we also have the chain rule. So the derivative of the derivative of inverse sine of u equals 1 over the square root of 1 minus u squared times the derivative at u. The derivative of inverse cosine at u equals -1 over the square root of 1 minus u squared times the derivative at u. The derivative of inverse tangent at u is 1 over 1 plus u squared du dx. And the derivative of inverse cotangent at u is -1 over 1 plus u squared times the derivative at u. The derivative of inverse secant at u equals 1 over the absolute value of u times the square root of u squared -1 du dx. And finally, the derivative of cosecant inverse at u equals -1 over the absolute value of u times the square root of u squared -1 du dx. Okay, so once again, you have to memorize formulas. If you set them up the way they're set up, you'll notice there's similarities by row and then by column as well. Okay, so let's go ahead and look at this next question. It says a proof. Prove that the derivative of inverse sine of x equals 1 over the square root of 1 minus x squared. Okay, so let's start with the argument that y equals inverse sine of x, or cosine x. So if that is true, then sine at y equals x. Because if I take and multiply y by sine and inverse sine by sine, I will get that statement sine y equals x. Remember that x has to be an element from -1 to 1. That's my domain, and my range has to be a value between negative pi over 2 and pi over 2, including those endpoints. Okay, so being that said, let's go ahead and take the derivative starting here. So if we take the derivative of this side, so we have d dx of sine y, and we're taking the derivative of the other side, d dx of x, what happens when we do that? Well, the derivative of sine y is cosine y. And the derivative of x is 1. And let me just kick back there, because whenever we take the derivative of y, remember I have to put dy dx next to it. So this next step looks like cosine y dy dx equals 1. So now my next step is to get dy dx by itself. So I'm going to go ahead and divide both sides by cosine y. So I'm here. And now I have 1 over cosine of y, and I can use substitution because I know y equals inverse sine x, right? So I have cosine of inverse sine at x. Okay? So what is the value? The value is x, right? And I'm going to go ahead and try to figure out what inverse sine of x is. So I'm going to have to draw a triangle. And I'm also going to have to know that sine theta is equivalent to opposite over the hypotenuse. Okay? Because x is an element from -1 to 1, I'm going to go ahead and make the hypotenuse 1. Okay, so here's x over here. I'm looking for side A. What is side A? Okay, so I'm trying to find that. So I get a squared plus x squared equals 1 squared. So a squared equals 1 minus x squared. A equals the square root of 1 minus x squared. Okay? So now if I plug in what I just found, 1 minus x squared, in for inverse sine of x, because we just found out what that equals, we get the statement 1 over the square root of 1 minus x squared. Okay, so there you go. So that's how we got that. Okay, so let's look at example number 1. By the way, I won't have one of those on your test, but example 1 would be fair game. Find the derivative of y equals inverse sine of x cubed. Now I'm looking at this and I know that I'm going to have to use the chain rule. So remember, we have to do the derivative of the outside first, right? Okay, so I'm going to take the 3 and bring that down there. So I have inverse sine of x squared. And then I have to take the derivative of the inside. And we just know that the derivative of inverse sine of x is 1 over the square root of 1 minus sine x. Okay, so if I put the pieces together, I get 3 times inverse sine at x squared all over the square root of 1 minus x squared. So this is my answer for example number 1. Okay, for example number 2, it says find the derivative of the inverse cosine at 2x. Okay, so I'm going to have to find the rule. So I'm going to go ahead and put the rule over here. So we know that the derivative or let me write this. Let's put the, so if my original function is cosine inverse at u, because remember this is complicated, it's not just x, it's 2x, then we know the derivative is going to equal 1 and it's negative over the square root of 1 minus u squared times du dx. So that's my rule. So let's go ahead and plug and chug here. So if I have the rule down, I know that the derivative at x is going to equal negative 1 over the square root of 1. Now u is 2x, so it's going to be 1 minus 2x squared. And then I have to take the derivative of 2x, which is 2. Okay, so let's clean this up a little bit and go from there. So if we clean it up, we get negative 2 in the numerator over the square root of 1 minus 4x squared. And that is my answer. Okay, example number 3, find the derivative g at t equals inverse tangent of e to the 3t. Once again, this guy's complicated, so we know we're going to have to use the chain rule. So I'm going to put the rule for this one. So if we know the original function is inverse tangent at u, the derivative is 1 over 1 plus u squared times du dx. Okay, so let's go ahead and plug and chug this. So the derivative at gt equals 1 over 1 plus 3 e to the 3t squared. And then I'm going to take the derivative of e to the 3t. So the derivative of this would be e to the 3t. I have to use the chain rule on this, so it's multiplied by 3. Okay? Alright, so let's clean this up. So we get 3e to the 3t over 1 plus e to the 6t. Okay, so here is our answer. And we're ready for the next example. So example number 4 says find the derivative of y equals inverse secant of 3x to the 5th. So this is complicated because my inside function is not just x, so I know I have to use the chain rule on this. So I'm going to go ahead and write the rule first. So I know if my original function is secant, inverse secant at u, then my derivative is going to be 1 over the absolute value of u times the square root of u squared minus 1 times du dx. Okay, so let's go ahead and plug and play. So the derivative of this is going to be 1 over, u is 3x to the 5th, take the absolute value of that, times the square root of 3x to the 5th squared minus 1. And then we're going to have to take the derivative of 3x to the 5th. Okay, so if I take the derivative of that, I get 3 times 5x to the 4th. Okay, all right, so let's clean this up. So in the numerator, I have 15x to the 4th. And then I have the absolute value of 3x to the 5th. And then we have the square root of 9x to the 10th minus 1. Okay, the only thing you can do is you can take the 3 out of the absolute value sign. And if you do that, that allows you to simplify down a little bit more. Okay, so this is what I'm doing is I'm taking the 3 outside of the absolute value. When I do that, I can simplify this down. And you can also put x to the fourth inside absolute value because that's always positive because it's an even power. So when we do that and we simplify everything down, 3 goes into 15 5 times, and then I can simplify this as well, and I get the absolute value of x in the denominator, not the numerator. So we got a 5 up here, absolute value of x in the denominator, and then we have the square root of 9 x to the 10th minus 1. And that's about as far as you can go with this one. And there's one more page to this, and this page basically goes all over every single derivative we have covered so far. So please make sure to look over this page. You know, we go over the constant, the power chain rule, the power rule, like e raised to the power. What do we do with that? B raised to the power, remember that's a constant. What do I do with a constant? Sum or difference, product rule, quotient rule, the derivative of the natural log of u, the derivative of log base b at u, sine, cosine, tangent, cotangent, secant, cosecant, inverse sine, inverse cosine, inverse tangent, inverse cotangent, inverse cosecant, and inverse secant. So there's examples for every single rule, so you can check it out. Like I said, you should be able to do all of these for the next test. So please spend some time memorizing, especially the inverse trig functions. I think those are the ones that people usually forget about. Okay, that's it for section 3.9. I'll see you in class.